This is Advanced Math, Unit 7, Lesson 2. Right triangle word problems. Number 1, from a point 50 feet in front of a building. From a point 50 feet in front of a building, the angles of elevation to the base of a sign and the top of the sign are 45 degrees and 47.75 degrees. Find the height of the sign. Okay, typical type of test question. In the beginning, on the book assignments for now, the pictures will be given. The picture will be drawn for you. But as we go and we continue to get more practice, by test day they will not be drawn. You will need to know how to draw these pictures on your own. For now, we'll get the practice with pictures being given to us, but eventually we're going to get to the point where we can draw them on our own. Okay, so here's my building from a point 50 feet in front of the building. So I'm going to call this the front of my building, and I walk away 50 feet. So I'm going to call that point right there. Actually, I'm going to go out a little bit further just so I have room in my picture. I'm going to go out 50 feet there. From a point 50 feet in front of a building. So here's the front of my building, 50 feet away. The angles of elevation to the base of a sign and the top of the sign are 45 degrees and 47.75. So there is like this billboard type sign up on this building. Advertising, whatever it's advertising. Okay, so there's this sign on top of the building. Here's the base of the sign, here's the top of the sign. So it says the angles of elevation to the base of the sign and the top of the sign are these two numbers respectively. You did these back in Math 2. And if you remember, angles of elevation always come from the ground. So from here, you're looking up to the base of the sign. That angle there is 45 degrees. And then to the top of the sign, so from the same point to the top of the sign, the angle of elevation is 47.75. So the bigger angle here is 47.75 degrees, which makes sense. It's a little bigger because from here you're looking up, but then you have to look further up to see the top of the sign. Okay, the question here is find the height of the sign. We're looking for this height right here. How high is the sign? Not the building and the sign, just the sign. Now, we talked in class about using SOHCAHTOA right triangle trig, which is what we're still going to be using. And it says right here, right triangles. So we need to look for our right triangles. Can you see that we have a right triangle here? Because there is a right angle. And I have two right triangles. I have this smaller one here where the base is 50. I don't know the height, and the angle is 45. The base is 50. I don't know the height or the hypotenuse, and the angle is 45. And then I have this bigger right triangle. The base is still 50. I still don't know the height or the hypotenuse, and this angle is 47.75. Okay, now it would be ideal to just use this little triangle, and with this little triangle I could find the little angle and then use that to find the height. That's ideal, but the reason we cannot do that is because this small triangle there is not a right triangle, and we're working with right triangles today. So again, if I wanted to use that small triangle to find this little orange line here, I can't do that because it's not a right triangle. So how can I use the small right triangle and the large right triangle to find the height of the sine? Okay, so what we're going to do is find, using right triangle trig, I'm just going to outline this a little bit, using right triangle trig, find the height of our big triangle. Find the height of the big triangle. And then, again, still using right triangle trig, find the height of our small triangle. And then we're going to do the big height of the big triangle minus the height of the small triangle, and that would leave us with the height of the sine. Do you see that? Height of the big triangle. Take away this purple line here, the height of the small triangle will leave me with the height of the sine, which is what I'm looking for. Okay, so let's write that down. We are going to do height of big triangle, take away height of small triangle. Okay, so let's just draw them out. The bigger triangle, I'm going to draw here. The base is 50. I don't know what the height is, so I'll just call it x. And I put the 50 in the wrong spot. The base is 50. I said it right. I just wrote it wrong. Sorry. Base is 50. We don't know the height, and the angle of elevation is 45 degrees. And then the smaller triangle, sorry guys, I would restart, but I don't have time, so I'm just going to continue. 47.75, and I will get this right. Okay, so big triangle is the blue one here. Base is 50. We don't know the height, and the angle of elevation is 47.75. Again, because that's the bigger triangle first. And then I'm going to draw the small one second. Height is still 50. Base is still 50. We don't know the height. I'm going to use a different variable, so I'm going to call it y. So the two bases are the same, 50 and 50. Height is x, height is y, and the angle of elevation is 45 degrees. All right, so what have we done? Big triangle here, height is x. Small triangle here, height is y. Big triangle, 47.75 for the angle of elevation. Small triangle, 45 degrees for the angle of elevation, and they both have the same base of 50 feet. All right, we can use SOHCAHTOA here to find x, to find y, and then we're going to do x minus y to find the height of the sine. Okay, this is the angle we're working with. In reference to this angle, that's opposite, that's adjacent, so we will be using tangent. Tangent of 47.75 equals x over 50. Multiply both sides by 50. And you plug in your calculator. You should have your scientific calculators. And you plug in 50. Don't know if you guys can see that very well. 50 times tangent of 47.75. You can't see it very well because of the lighting in the classroom, but you can plug it in your own calculators. You can kind of see it. 55.046 when you round to the nearest thousandths. Okay, so this is 55.046. Again, I just typed into my calculator 50 times tangent 47.75. Got this as my answer. Okay, for this one, I'm going to use tangent again because this is 45, opposite over oh, excuse me. Opposite over adjacent, so tangent of 45 oh, excuse me, equals y over 50 multiply both sides by the 50. Y equals, plug it in your calculator, 50 times tangent of 45. 50 times tangent of 45. When you plug it in, you really don't have to plug it in. I'm going to 50 times tangent of 45. It should come out to be 50, and I'm hoping you can see why. Again, the lighting's really bad. But it's okay, because you have your own calculators you can plug it into. It's just not going to show up. It does come out to be 50 because tangent of 45 is 1. We learned that, you learned that last year. Okay, so y equals 50 because 50 times 1 is 50. Okay, so this is the height of the big, this is the height of the small. 55.046, take away the 50. The height of the sign is 5.046 feet. All right, next problem. Next thing we're going to talk about before we do the next problem is bearings and what are bearings and how do they work. Okay. A bearing is an angle made with north and south lines. Bearings. A bearing is an angle made with north and south lines. So remembering your north and south lines, north, south, west, east. We will be using that north, south, west, east. So you need to know which one's north, which one's south, which one's west and east. You may have learned never eat soggy waffles. However you may have learned it back in the day, you do need it for the rest of these lessons. Okay, so you're going to see stuff like this. In 30 degrees E. The first one will always be in or S because it says here using north and south lines is what we always start with. We always start with north or south, and we always end with west or east. Okay, so north, what you're going to do is draw a line facing north. So I'm just going to start with the point, and if I'm facing north, my arrow would be going upward. Okay, so that's my north line. From there, picture like a little point here, and you're going to swing that arrow right or left. East is to the right, so you're going to take this arrow and swing it not just to the right, but 30 degrees. So approximate, for example, that would not be a good approximation for 30 degrees because that looks closer to 90 degrees. So approximate where 30 degrees would be. And it doesn't have to be exact, but that there would be your north 30 degrees east. Let's try another one. South 47 degrees west. Okay, so again, we always start with north or south. Draw your point. A south line would be pointing downwards. Your original line will always be pointing up or down. Your original line will always be vertical, but your arrow is either going up for north or down for south. Okay, so picture again like a little tack here holding this, and you're going to swing your arrow right or left. And west is to the left, so we're going to swing 47 degrees to the left. And again, you're just approximating. All right, let's try one more. In 17 degrees W, north 17 degrees west. Okay, so here's my dot. My arrow going north is going upward. Again, picture a little tack here, and you're going to swing that arrow right or left. West is to the left, so you're going to swing 17 degrees. Now 17 degrees is very small, so I'm just going to make it a little bit bigger just so I can make it clean. North 17 degrees west. All right, so let's try an actual word problem with bearings. Number 2. Boat A leaves dock going north. Boat B leaves dock going north 37 degrees east, in 37E. Now we use bearings, people use bearings out in the ocean because you can't just say go 5 miles down Shaw and then make a right on Blackstone. You can't say that kind of stuff when you're in the ocean. Turn right, turn left, or go this way, go that way, because there's no streets, there's nothing to guide you. So you use bearings in north and south and west and east to situate yourself and where you need to be. Okay, boat A leaves dock going north, straight north. Boat B leaves dock going north 37 degrees east at 27 miles per hour. After 3 hours, boat A is exactly due west of boat B. How far apart are they? How far apart are they? All right, so boat A leaves dock going north. Okay, so I'm going to start with boat A. And boat A goes north, so it's not going any west or east, it's just going straight north. We don't know how far, we don't know how fast, we just know it's heading north. Boat B, so I'm going to put up here, this is boat A. After 3 hours, this right here is boat A. Okay, boat B leaves the same dock going north 37 degrees east. Okay, so here's the dock. I draw my north line. We already have this vertical line there, so that's going to be my north line. What is it? 37 degrees east, so going this way. Draw an angle that's approximately 37 degrees. Now after 3 hours, boat A is exactly due west of boat B. Okay, what does that mean? That means we have a right triangle. If boat A is exactly due west of boat B, these are, this is a horizontal line. And if this is a north line, that's a vertical line, so this is a right triangle. How far apart are they? So we're looking for this right here. I'm going to call that X. Now how can I use, there's some information in here I haven't used to help me find this length here. I haven't used the 27. So is it okay to just put 27 here? It is not, because this is 27 miles per hour. That's a speed, where this is a length. This is the distance traveled, and distance equals rate times time. So if they're traveling 27 miles per hour, how far are they after 3 hours? 27 times 3. So the distance is 81. So 81 is the number that I put there, 81 miles. After 3 hours, boat B is 81 miles from the port. We don't know how far boat A is, but we don't need it to find how far apart they are, because we can use our SOHCAHTOA. Okay, here's the angle. This is the hypotenuse. X is opposite. Opposite over hypotenuse is sine. So we're going to do sine of an angle, 37, equals opposite x, 81, and solve. Multiply both sides by 81. Gone. 81 times sine of 37, sorry, is what you're going to plug in your calculator. 81 times sine of 37. Again, because of the lighting, you can't see my calculator very well, but you can plug it in on your own. Okay. Well, it says as an answer, and again, you should be plugging it in to get the practice, 48.747. 48.747 miles. That's how far apart they are after 3 hours. 48.747 miles. All right, we do have one more problem that I'm going to save for class. So when we come back into class, on our next class session, I will do number 3 with you guys. That's it for this lesson.